Hi, this is Bill Punch with another video from a series of videos on the practice of computing using Python, CSE 231 out of Michigan State University. Today we're going to cover exceptions, some of the elements that we left out in our previous coverage of exceptions, and show you some more details. Let's go ahead and get started. We know a lot about how to work with exceptions. We've worked with them before. Roughly they look like this. We have a try block. If an error occurs in the try block, we have except clauses looking for that particular error. If that error is found, we execute that. If the try block finishes successfully, we skipped all the excepts. Either way, no matter how we get out, we go on to the next lining process. We want to add a couple of keywords to this, the else and the finally keyword. The else clause is used when the try block finishes successfully without error. It's kind of the anti-exception. It's a little strange to think why would we have it, but here from the documentation is a pretty nice description. Under the circumstances, we want to put in the try clause those things that we think are going to cause errors, and then we want to separate from that try clause those things that we want to do as part of the normal processing. If we can keep those two things separate and the else clause allows us to do that, it's easier to do our work. The second element is the finally clause, and this is kind of interesting. We call it the no matter what clause. No matter what, no matter how the exception ends, if it's an error, non-error, a break, a raise, anything, the finally block always executes no matter what the situation is. So if we put all that together, this would be a full implementation of all the elements of an exception. One thing I think it's interesting to note, here's an except with an error, here's an except with an error, and here's an except no particular error. The way that would work is if the try block throws an error and it's not one of the two errors that we're watching for, this is the default except suite. We would go to this exception under every other circumstance except those errors that we were watching for. That can be kind of unusual. It's a little hard to know just exactly how we got to this because we don't know what error we were looking for. Still, it's useful to do. Else runs when the try block finishes successfully, finally runs no matter what. Here's a simple example of putting this all together. We have a file object which we start out with none, and our goal is to try to open that file object, and we're going to open it for writing someplace on the directory tmp file.txt. If we cannot open the file, we get an IO error, and by the way, in Python 3.3 it's called a file not found error, no longer an IO error. We print out a message. Otherwise, if we can open the file object, we want to go ahead and print and write to the file, and then finally on the way out we want to close the file. Interestingly, file object starts out as none, and if it opens successfully, then file object will be of type from the IO module, IO text IO wrapper, which we can then close. If it's not of that type, then file object didn't get open, it's equal to none, and we just print no file to close. If we run this, it runs successfully to TMP. If I change it to TEMP, a non-existent directory, it says it can't open it, and either way the finally executes on the way out. Another thing we can do is we can raise errors whenever we choose. So we, the programmer, can say, hey, something's bad going on here. I want to raise an exception. And when we raise the exception, we can pass a value to the exception. And if you look at this a little more closely, it looks very much like a constructor. We're creating a new instance, and this is the initializer value. When we catch the exception, we can catch it as the instance, and then we can print the instance, and information that was stored in value can be printed. Finally, we can also create our own exceptions. Every exception is a particular class. We can subclass the exception, which is what we've done here. My exception, a new exception, is going to be made as a subclass of exception. Typically, we provide two methods in this. An init method, which calls the parent, and a string. We would create an exception if we've created a new class and a special error, one that does not exist yet in Python, is needed to describe something that goes wrong. Here's a pretty simple example. This is a linear search. Starting with element 0, we look for every element of the list, and if that element is equal to the value that was passed in, the thing that we're looking for, we return count, the index as to where it occurred. If we get all the way through this and none of these values return, then we raise the exception and we raise it with the value that we were looking for, so that information is stored. When we catch it, we try it below. If we catch that error, we catch it as the particular element, and we can print it out using the string value list to see what value we were looking for when it died. Otherwise, we say it works, and either way, on the way out, we print where we were when we were running. So 10 was not on the list. We were going out on index 0. If we look for 9, which is in the list, it says we found it at index 4 and went out with a value of 4. We raised our own error, we created our own error, and we used some of the extra else and finally clauses to put this all together as one big piece.